Hi, everyone. Thank you for joining me for my talk today. Just to introduce myself, but I'll do it again for the camera. I'm Susannah. I'm the product lead at the IBC team at Interchain. And today, I'm going to focus a bit more on applications you can build with IBC. And I'm going to really frame that towards a more Ethereum audience. First of all, I'll touch on what do we actually mean when we talk about interoperability, and what does interoperability actually look like on Ethereum right now, and especially with regards to application developments. Then that brings me nicely onto talking about IBC, and I'll do a comparison of how liquid staking operates in Ethereum, and then in a more cross-chain environment, and then just finish on thinking about what the future of Ethereum might look like in a more cross-chain world. So let's get started. So when we talk about interoperability, what do we mean? So we mean connecting different domains, making sure that there's no silos of value. This could be monetary, data, whatever. And specifically in Ethereum, I think when we talk about interoperability, we're talking about token transfers. There's increasingly a bit more of a trend to think about general message passing and arbitrary data transfer, but mostly we're focused on this kind of token transfer bridge space. And what does that look like in terms of applications deployed on Ethereum? So I think predominantly, although we do have some different cases, a lot of the domains that are connecting into Ethereum, different EVM kind of compatible chains or rollups, you'll often see the same application deployed again in a different domain. So it's basically just the same contract redeployed on a sidechain or a rollup. I've given the example here of Uniswap. There are instances of Uniswaps across all of these domains, but all of these instances of Uniswap exist in isolation. So they're not connected, and the way you kind of reach this new instance of Uniswap is by transferring your tokens with a bridge. So the second scenario that we see a bit of, but less so than this multi-chain scenario, is domain-specific application deployments. So this is where you have an application that can only be deployed in a specific domain due to some design constraints. So an example could be that there might be a rollup that's already deployed a specific ERC, such as account abstraction, which then enables you to build an account abstraction wallet. Or we saw this domain-specific deployment with DYDX. They were previously a rollup, and then they transitioned to build their own Cosmos app chain because they wanted to customize their order book and have more control of their consensus, which just wasn't possible with the Starknet rollup that they started as. But again, with these domain-specific rollups, not just rollups, applications, you generally connect them with token transfer. Again, people are just moving tokens from one domain to another to then use that specific application. And then there's kind of a third type of applications that you can have in an interoperable world. And I'd call these cross-chain. And this is kind of the next step on top of domain-specific applications. So here you're actually leveraging the best parts of multiple domains and then creating an application which is connected and using both of these for their kind of core purpose. So the example here, there's an application called Similia, and they offer vaults that you can get yield on your Ethereum, or they offer a range of vaults. But the way they do this is they have strategies which are based off of off-chain data. Then they have a Cosmos chain, and validators come to consensus on the specific management that they will do on a vault. And then they send the message for the vault management from this Cosmos chain to Ethereum with their own kind of validator-operated bridge. So this is really leveraging kind of the liquidity and vaults that you have on Ethereum, whilst also leveraging the power of a Cosmos chain. So it's a genuinely cross-chain application. So just to summarize, these are kind of the options we have. Each of them come with their own trade-offs and benefits. Multi-chain is clearly the easiest to deploy, especially if you're kind of moving between different EVM ecosystems. You just use your existing smart contracts, redeploy them elsewhere. But you've got no connectivity and everything's a bit fragmented, right? You can fork the app, but you can't fork the liquidity. Domain specific, it's great that you can kind of do more advanced things with your application based on specific domains architecture and technology, but you're inherently limited to where you can deploy that application. And cross-chain is kind of the best of both worlds. However, it's just inherently going to be more complicated to deploy when you're dealing with multiple domains. And kind of, people touched on this earlier, but if you're building something cross-chain in a decentralized system, and then you're happy to just add in some kind of additional trusted party, what's really the point in building a decentralized application in the first place? So it's only going to work best when you have interoperability without additional trust assumptions. And if we take a look at interoperability in Ethereum today, this is a kind of a screenshot from DeFi Llama. It's showing the top 10, the top 5, sorry, I can't count. The top 5 bridges by activity that we see. Most of these are the native bridges, or you've got some third-party bridges. And it's basically mostly token transfer that we're talking about. So in kind of the Ethereum world, we're just moving tokens between domains. And interestingly, it's actually predominantly stablecoins. There was a statistic I found through someone's student dashboard that actually 99% of bridge deposits are USDC. So yeah, it's just moving tokens around, which kind of, to me, signifies that we're very much in this multi-chain world. And when people are doing these token transfers, they're using bridges. Typically, this is kind of representative of what a bridge looks like today. So you've got smart contracts on a source chain, you've got smart contracts on a remote chain, and you've got some kind of validator set that's verifying some action took place on the source chain and then authorizing you to perform some action on the remote chain. And then often you'll have some kind of relayer which is actually transmitting the messages from source to destination. So some of the challenges there, I think lots of people have already touched on this, but we see so many different bridges kind of in the Ethereum space today, and they all have their own smart contracts. They've all got their own bespoke relayer implementation. There's no kind of harmony between all these different bridges. And, coming back to working in decentralized systems, if we're happy to then add in an additional trust assumption to our application or use case, what's kind of the point in the first place? So having these additional trust assumptions just weakens the kind of, your trust assumption is now dependent on the bridge validator set rather than your underlying application. And so that's what interoperability looks like today in Ethereum, but what about tomorrow? And there's been a lot of talk about rollups and lots of rollup frameworks and things like this. And it seems like now we have Ethereum connecting to a few domains, but it's not inconceivable that Ethereum is going to be connecting to a lot of different domains in the future. And if we kind of carry on with that status quo of bridge providers, I think we're going to face a lot of challenges, and applications are certainly going to stay in that multi-chain kind of fragmented space. So this brings me on quite nicely to talk about IBC. So at a high level, what makes IBC really different from existing bridges are the abstraction layers. So IBC is an interoperability protocol that allows you to permissionlessly move data, tokens, whatever you want between two domains. And the benefit that it offers is these really clean abstractions. So at the application layer, what we mean is the message that you actually want to pass between the two chains. So it could be tokens, it could just be a message, it could be any kind of data. The transport layer is how you get the message from one domain to another. And the state layer is how you actually verify that some action took place on one chain. And in IBC, you've got a lot of flexibility by having this well-defined transport layer. So Aditya had already spoken about clients, and that's what forms the basis of the state layer. But IBC offers this flexibility that you can have different trust assumptions depending on your use case. So if you want to only trust the two domains you want to interoperate with, you'd use a light client. If you don't mind trusting someone else, you can use a solo machine client. It's kind of equivalent to a multisig. Transport layer has connections, which verifies that the client you have is actually representative of your counterparty, and channels, which is where you actually send data from chain A to chain B. And relays are the permissionless actor who are moving these data packets from chain A to chain B. And then on the application layer, you have application modules, you can have smart contracts, and these modules or contracts are responsible for interpreting the messages that are sent between chains, decoding the data encompassed in the packets. And one thing I really want to highlight is by having this standardized transport layer, a relayer's job is the same for every single application. So they just need to update light clients and move the packets from chain A to chain B. This could be a token transfer. It could be a interchain accounts transaction. It could be a smart contract call. It could be just sending some Oracle data from one chain to another. But the packet lifecycle is the same. So that brings me on to just introduce what is the IBC packet lifecycle. So you could be a human that wants to use IBC, or you could be a smart contract. So you'd interact with your application, you'd create a packet commitment, this gets passed on to the transport layer, and then a relay is going to query for this packet commitment. They'll verify on the receiving chain that this packet commitment was actually made on the sending chain, and then they'll be able to pass that packet onto the receiving chain, onto the transport layer at B. Then this packet gets passed on to the application on chain B. The application will do all of the application logic it needs to do. So in the case of a token transfer, you would be minting vouchers on chain B. And then you can have a callback to a smart contract on chain B, optionally. And you also then have an acknowledgement to say, I've minted these vouchers. I'm going to let the sending chain know that I've actually done my job correctly. So then you pass an acknowledgement back from the application to the transport layer. Again, the relayer just queries for this packet. They then verify that this packet was actually committed on the receiving chain. And then this gets passed back to the application on chain A. And you can optionally have a callback to a smart contract who might be then performing another action based on the fact that this token transfer has happened and been successful. And what I really want to emphasize is that this packet lifecycle is the same for any application that's going to be used with IBC. So you can innovate on the application layer really nicely with IBC and not have to worry about having like bespoke relay, custom smart contract every time you want to create a new application. So yeah, just to compare how IBC is compared to typical bridges, new smart contract for every bridge application. You need custom relay. And typically with bridges, you might like send the token and then you kind of fire it into the ether. You hope that it's received by your counterparty, but there's nothing on chain to tell you like whether it actually was successfully received or not. I think if we want to start building more complicated applications, that's kind of like a minimum prerequisite needed. You want to do something after you know someone received your tokens. Right now, you can't really do that. But with IBC, you've got this generic packet lifecycle for every application, no custom relay needed. You have acknowledgements and timeouts. I showed the happy path of a packet being delivered to a counterparty. But if a relay doesn't pick up your packet, there's something called a timeout, which verifies that your packet wasn't delivered within a given time frame, so that you're not just kind of hanging and waiting forever with your tokens locked in an escrow account. And another nice thing about the transport layer being standardized is that you can extend existing applications for all applications. So an example of this is relayer incentives. So it's implemented as a middleware so that you can add these incentives to any application, not just token transfer. Okay, and then we'll just look at how liquid staking works on Ethereum right now, and how it works in kind of the Cosmos ecosystem, a more kind of cross-chain space. Okay, so liquid staking is a pretty big thing in Ethereum, and I think the biggest player is certainly Lido. This diagram's a little dated because it was before ETH2, but the principle of how liquid staking works is still the same. So with liquid staking, it's a way for you to still keep hold of your token whilst benefiting from the rewards of having staked ETH. Another constraint is that you need 32 ETH to run a validator, and lots of people don't have that much ETH just lying around. So as a user, you can deposit your ETH into a liquid staking contract, and you receive staked ETH in return. Under the hood, you have node operators who are running validating nodes, and the Lido staking contracts will distribute the Ethereum that's been deposited by users to various validators, and then they will actually run these validating nodes. And there's also contracts to manage withdrawal. So if I'm a user and I say, actually, I want to give my staked ETH back and get my ETH back, then under the hood, you actually want to reduce the amount of ETH that's being staked by the Lido validators. So there's some contracts which manage deposits and withdrawals as well. And for a user, you just kind of head over to the Lido app, and you'll just see a very simple user interface. So you'll just select your Ethereum amount you want to deposit, connect your wallet, do all that. And then because staked ETH has had much popularity on Ethereum, we've seen like different rollups also want to use this staked ETH in specific applications or DeFi opportunities. So the way Lido has done this is because staked ETH is a rebasing token. They've just created a kind of wrapper contract where you deposit your staked ETH into this contract. In return, you get wrapped stake ETH, which doesn't rebase. And then you can bridge that to Optimism or Base or Arbitrum. So it feels very kind of multi-chain in the sense of you're still using this token, but it's just through kind of the native bridges. If we compare that to how liquid staking works in the Cosmos ecosystem, so we have pretty much the same interface. You just decide the amount of Atom. Atom is the token of the Cosmos hub. How much Atom you want to turn into staked Atom. You connect your wallet, and it's pretty much the same process. However, under the hood, the process is quite a lot different. So it's still one click for the user, but what's actually happening is they're transferring their atom from the Cosmos hub to the Stride blockchain. Then this atom gets deposited into the liquid staking account on Stride. They'll then mint the staked atom, and then they'll send it back to the user so that they then get their staked atom. But if we take a closer look into what's going on with this liquid staking account, we use quite a range of functionality of IBC applications. So we've got a token transfer sending the atom from Stride to Cosmos. And then the Stride blockchain will send an Interchain account message to an Interchain account that they created on Cosmos. So an Interchain account is just an account that can be controlled remotely from a different blockchain. And this account is used to aggregate all of the atom, which is then being staked, to then back the staked atom that's being minted for the end user. So they can then send messages to this Interchain account to stake the atom. They can send a message to claim the staking rewards. And they can also query the account balance of the Interchain account to know, okay, we now have this much atom, we just claimed this much reward. Let's recompound 90% of the rewards and use kind of 10% as a protocol fee. And how this then works in a kind of cross-chain world is that's the service for the Cosmos Hub, but actually it scales to all the different Cosmos blockchains. So Stride has the same application. They just deploy an Interchain account on all of these different blockchains, and then they can mint staked assets of all these different blockchains, native tokens, and this is all leveraging IBC, Interchain accounts, Interchain queries, and token transfer. And inherently, the ecosystems are just different. And I don't think the point is to say one instance is better than the other. But this example just highlights how things might look different for applications in the future when you move more towards a cross-chain world. Because the question is it scalable to just be redeploying the same app everywhere? Or could we actually start building these natively cross-chain apps? So that brings me to the close and thinking about the cross-chain future. So we've seen an explosion of roll-up frameworks coming to the market. You've got, the Polygon CDK, the OP Stack, Arbitrum Nova, ZK Sync Era. I think it's not inconceivable to think there are many frameworks. We're probably going to be seeing a hell of a lot more roll-ups in the future. And then with that, are we going to kind of see a more multi-chain world, like with all these additional roll-ups? Are we just going to see exactly the same applications deployed everywhere? Are we going to start seeing some specialization? Certain roll-up frameworks will offer you certain advantages that you can then use to your advantage and benefit in your specific application. Or are we going to start seeing a more cross-chain world where you'll see one roll-up, app-specific roll-up, leveraging an application on another roll-up? And I think if we actually do start seeing a more cross-chain future, it's already kind of resembling something that we saw a bit in the Cosmos ecosystem. And one of the main differences between what we have in Cosmos and what we have in Ethereum is this interoperability standard of IBC. Like, this is not really materialized yet in Ethereum. And, for example, you could see an application where you've already KYC'd on Base, and you then want to open an Interchain account on another rollup to then leverage some kind of KYC-gated application there. So you could do this really nicely if you had a unified interoperability standard for all of these rollups, because then you wouldn't have to deploy a bespoke relay for every single application that you want to leverage your credentials on. It would just make things a lot more seamless if we are going to move towards this cross-chain future. And having something akin to the inter-blockchain communication protocol could quite nicely solve these issues and enable different application-specific rollups to actually leverage applications from other chains. So yeah, thank you for listening to my talk.